Hello everyone and welcome back to my channel. First of all, I want to congratulate you all for reaching this long. We are now in our 8th module in your first quarter in Mathematics 7. And our topic for today is all about estimating the square roots of whole numbers and plotting irrational numbers. If you haven't subscribed to my channel yet, please click the subscribe button and the bell button for notifications. In our previous video, we have talked about determining which two consecutive integers the square root of a number lie. If you haven't watched that video, please click the suggested video above. For today, we are going to talk about estimating the square root of whole number to the nearest hundredths. When you are finding the square root of a perfect square number using a calculator, you probably noticed that the answer is a whole number. On the other hand, each time you find the square root of numbers that are not a perfect square, you will see several digits after the decimal point. This means the square root of that number is a whole number and some fraction of another. To determine the approximate value of the square root of a number that is not a perfect square, a series of estimation is made. I am going to introduce today 4 methods in estimating the square root, one of which is the best. It depends upon you which is more comfortable way for you to estimate or to compute. So I'm going to show you first our first method. Example is the square root of 7. For step 1, find the perfect squares closest, less than or greater than to the given number. Since 7 is not a perfect square, we need to find the 2 perfect squares that is closest to 7. They are 4 and 9 because the square root of 4 is less than the square root of 7 and is less than the square root of 9. Or 2 is less than the square root of 7, which is also less than 3. Therefore, the square root of 7 lies between 2 and 3. And since 7 is closer to 9 than 4, we know that the square root of 7 is closer to 3 than 2. Step 2. Make an educated guess to one decimal place and try it. Since we know that square root of 7 is closer to 3 than 2, we then square numbers closer to 3 with one decimal place. Let's have 2.5 squared that is equal to 6.25, 2.6 squared that is equal to 6.76, 2.7 squared is equal to 7.29, and 2.8 squared is equal to 7.84. The square root of 7 lies between 2.6 and 2.7. Note that squaring of 2.1, 2.2, 2.3, and 2.4 is not necessary, since square root of 7 is closer, 3. For step 3, we decide which is closer. Since 7 is closer to 6.76 compared to 7.29, and 6.76 is the square of 2.6, then estimate further by squaring the numbers 2.61, 2.62, 2.63, 2.64, and 2.65. Here are the squares of these numbers. Take note that squaring 2.66, 2.67, 2.68, and 2.69 is not necessary since the square root of 7 is closer to 2.6 than 2.7. Next, let's take note those squares. And you have noticed that 7 is closer to 7.02 compared to 6.96. Meanwhile, 7.02 is the square of 2.65. Hence, the square root of 7 is 2.65 when estimated to nearest hundredths. Now, I think it depends upon you. If you really want to multiply 3 digits by 3 digits, like you are going to multiply a lot of 3 digits in this kind of method. So if you're more comfortable with this method, you can use this. But let's see our second method. Our second method is more of like what we say the long division. This is the long process. It will take quite a long time, but it will give you a more accurate answer. Let's have the square root of 109. We put a line like that. First, group the numbers by 2 from right to left, leaving either 1 or 2 digits on the left, since we are going to start from the right. For each pair of numbers, you will get 1 digit in the square root. This is just like more of a division process, but it takes a lot of processes aside from what we are used to. So we group 1, 0, and 9 by 2. Starting from the right, we have 1 and then 0, 9. Next, to start, find a number whose square is less than or equal to the first pair or first number and write it above the line. And take note, our first number is 1. It is not a pair, it is just a number. The square root of 1 is equal to 1. Next, square the answer, write that underneath the first pair of digits and subtract. Bring down the next pair of digits. Now we square the answer, that is 1. 1 squared is equal 1. And then we subtract it from 1. The answer is 0. Then we bring down 9. Next, double the number above the line and write it down and put 3 boxes as shown. The number above the line is 1. We double it. 1 multiplied by 2 is equal to 2. Then we write 2 and put 3 boxes, just like that. I designed it color blue because these boxes means or corresponds to the same number. It means if I'm gonna put the number 1 in one of the boxes, I am also gonna put 1 in the other boxes. And then multiply. We think of what single-digit number something could go on the empty box so that the answer would be less than or equal to the number on the right. If you take note, the number on the right is 9. Let's try 0. 20 multiplied by 0 gives us 0. That is correct. That is less than 9. Let's try 1. 21 multiplied by 1 gives us 21. So that is an incorrect answer. 1 is incorrect because it is more than 9. 21 is more than 9. We are looking for a product that is less than the number on the right but is closest. So we will consider 0. Next, write the same number on the top of the line. As I have said earlier, the same number follows in the box. So the number is 0. You write it on the top of the line. Next, write the product on the right side to the left and subtract from the existing numbers. So the product is 0. We write it down. Then we subtract from the existing number, that is 9. The answer is 9. And then we bring down the next pair of digits. In this case, there are no next digits, so we affix the decimal point and then bring down 2 zeros. Affix a decimal point and 2 zeros, then bring the 2 zeros down. Of course, since we affix the decimal point, we also have to affix it in our answer. Now we have 900. We have to repeat step 4. Double the number above the line and write it down and put 3 boxes. Oh. Now we double 10, that is equal to 20, and then we put 3 boxes again. Next, the same step we have done earlier, thinking of a single-digit number, something could go on the empty box so that the answer would be less than or equal to the number on the right. This is a trial and error method. It just depends on how much you know about mathematics. And then you can find the answer faster. Or if you are proficient in multiplication, you can just find the answer right away. So let's try the first digit. 0 is less than, but it is far from 900. 1 is 201 multiplied by 1. 201 is still far from 900. Let's try 2. 2 gives us 404. 3 gives us 609. 4 gives us 816, which is quite close to 900, but we will try 5. 5 gives us 1025. Now that is greater than 900, so we will consider 4. Then, we write the same number on the top of the line, that is 4. And then write the product from the left side to the right side. The product is 816, write it down and subtract it from 900. The answer is 84. Since we do not have extra digits, we have to affix 2 zeros and bring them down.
Please click the subscribe button and bell button for notifications. Thank you.
Now let's continue. Since I don't have enough space, I just move it here and I put our first computation on the left side so that we will have a sort of guide on the process. Now next, you repeat steps 4, 5, and 6 until we achieve the decimal place that we need. So in this case, I am just going to compute up to 2 decimal places. So like we are going to compute up to 3 decimal places for us to distinguish whether we are going to round up or round down the hundredths place value. Now we have 8,400 from our previous division. Next, we take the answer, that is 104, and then double it. We have 208. Write it down on the left side and then put 3 boxes again. And then multiply. Think of a number that we can put in the boxes that will give us an answer that is less than or equal to 8,400. If it is less than, you have to consider that it is closer or the closest answer to 8,400. So if I am doing this kind of multiplication or this kind of division, I'm just looking at the numbers like 2,080 something. I am just going to round it off to 2,000, and then the 8,400, I'm going to round it off to 8,000. So since I know that there are 4 2,000s in 8,000, so I'm going to try first the number 4. It's going to give us 8,336, which is quite close to 8,400, and I guess this is the correct answer, but let us try 5. Now 5 gives us an answer that is greater than 8,400. So we are going to continue with 4. We write 4 in the box above or above the line. This is considered as our answer. And then we subtract 8,336 from 8,400. It gives us 64. Our next step is to affix 2 zeros and then bring it down. It gives us 6,400. Then the next step is to multiply 1,044, our answer, by 2. That gives us 2,088. And then writing it again, then 3 boxes again. Now, I'm not going to continue with this process because if I am going to put the number 1, consider it will be 20,000, more than 20,000, which means it would be greater than 6,400. So we automatically know that the answer in that box is 0. Therefore, our answer is 10 and 44 hundredths. That is rounded off to the nearest hundredths place value. So if you were asked for the nearest thousands or 10,000s, it would be better if you will continue this long division method. Now, I know that most of you are not comfortable with this kind of method because this is new. First, this is new. Second, it takes a lot of time. Third, it will take a lot of guessing and all. That's the reason why I'm going to introduce to you our third method. Our third method is called the Herons method. If you have heard about this before, comment down. If you have not, this is the best way to introduce to you the Herons method in estimating the square root. Let's have the square root of 146. In our Herons method, we let x is equal to guess. So what is the guess? The guess is it should be a principal root closest to the given. And then y is the radicand. We have our formula x plus y over x over 2, where x is of course the guess and y is the radicand. We all know that our radicand is 146, but let's take a guess. The square root of 144 is 12. The square root of 169 is 13. Now, take the number closest to 146, and that is 144. Now, we are going to consider x is equal to 12. Now, let's replace the variables. X is 12, so we put 12 plus, since y is 146, that is our numerator, and x again is the denominator, that is 12, and then divide it all by 2. But before that, we can apply the cancellation method as I have taught in my previous videos. We can still divide these numbers by 2. So dividing 146 by 2, we have 73, and 12 divided by 2 is 6. Now applying our butterfly method, 12 multiplied by 6 is 72, and then we add it up to 73. It gives a numerator that is 145 and a denominator that is 6, all over 2. That's our new fraction. And then, since we are applying division, in division of fractions, we take the reciprocal of the divisor and we multiply the fractions. Now, we have 145 over 6 multiplied by 1/2. Let's check, evaluate the fraction if we can cancel anything. And I think there's none. So, we end up with 145 over 12. Now, dividing 145 by 12, our answer is 12 and 800. Now, if you want to make sure if 12 and 800 is the correct answer, you can still undergo another step, which is our second step. So in our second step, our x will be 12 and 800, but it will take us quite some time to do this. Since I have already checked and verified that 12 and 800 is the correct answer, I will no longer proceed with the second step. But if you are uncertain of our first step, you can still consider second step, where x is equal to 12 and 800 and y is still equal to 146. We still undergo this same process like we have done in this method. And we have our fourth method. This is a method that I have seen most of the Chinese people do. I have even read an article that grade 2 Chinese students know about this. This is like, I don't know what this is called, but it is quite simple. Let's take the square root of 63. Now we find the same process. We are going to find square roots that are closer to 63, or where the square root of 63 lies in between, that is 7 and 8. And then we take the closest. The closest is 64. So since 64 is greater than 63, we are going to apply subtraction. So we take 8, subtraction, since 64 is greater than 63, and then we double 8. That becomes our denominator, that is 16. Then the distance from 64 to 63 is 1. That's our numerator. And then we subtract. 8 less 6 hundredths. Or if you're more comfortable with fractions, you can do it with the fractions, no problem. It will still give us the same answer. That is 7 and 94 hundredths. Now we are done with our lesson in estimating the square root of whole number to the nearest hundredths. I want to see in the comment section which of the 4 methods you would like to use, and tell me more about why are you going to use that kind of method. Stay tuned for my next lesson because I am going to talk about plotting radicals or the square root of numbers in the number line. This is more like something of my previous video, like determining which 2 positive integers the square root of a number line. But in this case, in our next lesson, we are going to plot it in the number line. So stay tuned and thank you for watching.